I will, yeah, and now it should be in presentation mode.
Right.
Yeah, okay, perfect. So good morning, everyone. So my name is Birgit Mertens, and I'm working at Cienzano. And within the Live VERMEER project, we have been involved in the case study on food contact materials. So today I will present to you the tool that has been developed, which is VEGA FCM. And in fact, the aim of this tool is to support the evaluation of the migration and hazard of chemicals present in food contact materials. So I will do the presentation, but for the modeling part, the migration model, this model has been developed by Dr. Philippe Sivroy. So he will make maybe some additions after the slides with respect to this migration model. So as already indicated in the previous presentations, the main aim of the Live VERMEER project was to combine, on one hand, models that provide you information on exposure with models to predict toxicological hazards into one platform that can be used to support the risk assessment of chemicals. And so there were multiple case studies, but this presentation will deal specifically with the case study on food contact materials, in which we thus developed the VERMEER FCM tool. Now, in order to better understand how we have developed this tool and how we would like to use the tool, I will first provide you some background information on food contact materials. So when talking about the possible risks associated with food contact materials, it's like for all chemicals important to look not only to the hazards, but also to the exposure part. And with respect to food contact materials, this exposure will be driven by the migration, because only in case you have migration from a compound from your food contact material into the food, there might in the end be a possible exposure to this compound. So within the VERMEER FCM tool, we just combined models to provide information on exposure, and then more specifically models to provide information on migration, with models that provide us information on the toxicological endpoints that are relevant for food contact materials. So when we talk about food contact materials, it's important to know that there are about 17 different types of food contact materials, including wood, paper and board, printing inks, glass, plastic, and so on. However, only for one type of these food contact materials, more specifically the plastic food contact materials, there exists a kind of positive list, which is Annex 1 of Regulation 10/2011. And this positive list provides an overview of the authorized substances that can be used as a starting substance in these FCM type. So when applicable, also a specific migration limit and the conditions, the restrictions for use are included in this Annex 1. If you want to include a new substance in this positive list, there is an entire procedure in place. So first of all, you need to compile as an applicant a dossier, which includes, amongst other, also toxicological information. Afterwards, this dossier will be evaluated by the European Food Safety Authority, which will then formulate recommendations to the European Commission. So it will then be decided whether or not the compound can be included in the positive list, and if certain restrictions of use or a specific migration limit apply to this substance. So the dossier contains, as I indicated before, also toxicological information, and the type and the amount of toxicological information that needs to be included is described in the notes for guidance for the preparation of an application for the safety assessment of a substance to be used in plastic food contact materials. And when you look a little bit more into detail in these toxicological requirements, you will see that the type and the amount of data is really driven by the migration level. So if you have very low migration, only genotoxicity data will be requested. However, if the migration is higher, you will also need to provide subchronic oral toxicity data and data to demonstrate the absence of an accumulation potential of the compound in man. And if the migration is even higher than the 5 milligrams per kilogram food, you have to provide more detailed toxicokinetic data, and you also have to provide data on reproductive and developmental toxicity and long-term toxicity or carcinogenicity data. So of course, as an applicant, it's already important very early in the development of your the new substance to be used in food contact materials to have a good indication of the migration of your compound and also the possible toxicological properties of your compound. And in that sense, the VERMEER FCM tool, as we will show you later, can thus be of high interest. On the other hand, the VERMEER FCM tool can also be of interest to assess the possible risk associated with NIAS. So these are the non-intentionally added substances. So these are impurities in the substance that is used, or they can also be reaction intermediates formed during the production process or a decomposition or reaction product. And these NIAS, they are permitted to be present in the final plastic article. However, the manufacturer also has to assess the possible risks of these NIAS in accordance with the international recognized scientific principles for risk assessment. And furthermore, the supplier also needs to guarantee the safety of the final product. And therefore, because currently clear guidance on how these NIAS should be assessed is missing, we think that also the VERMEER FCM tool could play an important role. So how did we then develop the tool? So in fact, what we did in several of the live VERMEER case studies was just to combine models for exposures that are present in the Merlin Expo software, which has been developed in a previous European project, with models for hazards that are available in the VEGA-HUB. Now, at the beginning of the project, within the Merlin Expo software, there was not yet a model available for migration from food contact materials. And for this reason, the first step was just to develop a model for migration from plastic food contact materials. So we have done that, and after that, the model was validated using experimental migration data. And then once this model was developed and validated, it was integrated into the Merlin Expo software. So it should be highlighted that the migration model was initially developed, as I will show you also later, specifically for plastic food contact materials, but it has then also been extended to other types of food contact materials. But there it should be noted that we are a bit struggling with the validation of this model because we don't have experimental data for that. So we have the model, but it needs to be further validated, and there we are still looking for good experimental data to do this validation exercise. So then a bit more information on the migration model. So as I just already highlighted, I have not developed this model by myself. This has been done by Philippe. So I will present you the slides, but then Philippe can make some additions after this presentation. So just important to know is that the migration has been, model has been developed for food contact material layers consisting of one layer. So it's not adapted to multi-layer food contact materials. So in case you have a food contact material layer, contact material consisting of one layer, the mass balance equation based on Fick's law is assumed to apply. And you see here this Fick's law, and this can then be used as a kind of analytical solution to model the migration. So here on this slide, you can see this the detailed formula that can just be used to model the mass of your targeted chemical in the food as a function of the time. And you see this that the mass depends on many different factors, such as the initial mass of your target chemical in the food contact material, the density of the food, and also the density of the food contact material. You also need to know the thickness of the food contact material and the food layers. You also need to have some information about the contact time between the food and the food contact material. And you also see here two coefficients that we need to know, so which is on one hand the diffusion coefficient of the chemical in the food contact material, and on the other hand, the partition coefficient of the chemical between the food and the food contact material. And in order to model these two parameters, we have applied some existing models. So this first of all for the diffusion coefficient, Piringer and colleagues have defined a model in 2007 for this diffusion coefficient, where you see this, that the diffusion coefficient is driven by the conductance of the food contact material, the molar mass of the migrating chemical, and the temperature. And this is in fact the model that is largely used also in other migration models for food contact materials, but it has been calibrated only for plastic food contact materials. So what we have done is, so we have developed a migration model based on this Piringer's model, but on the other hand, more recently, another model has been developed for the diffusion coefficient by Huang and colleagues. And this model has been calibrated for a wider range of food contact materials. So also a second migration model has been made based on Huang's model, but as I just explained, and there we are still progressing with the validation because we need more experimental data to do this validation. So currently, the migration model that is included in the VERMEER FCM tool is based thus on Piringer's model. On the other hand, for the partition coefficient, therefore the model of Huang et al. From 2019 was used, and this has been thus calibrated for a wide range of food contact materials, so not only plastics. So in the end, in order to be able to perform, to apply the migration model, what do we need? So we need different types of information to be able to run the model. So first of all, we need to have some information about our target chemical, so the compound for which we want to investigate the migration. And therefore, first of all, we also need to have the SMILES formula, because within the formula for modeling the migration, we also need to have information on the log P value. And this can be automatically predicted by the VEGA tools. But in order to do that, we need a SMILES code. And also, in order to be able to model the hazard endpoints, which I will discuss later, we also need to have this SMILES code. Normally the SMILES code, can be easily found in databases such as, for example, PubChem. On the other hand, you also need to know the initial concentration of your target chemical in your food contact material, and you need to know the molecular weight. Then you also need to have some information about your food contact material. So first of all, you need to know the type of the food contact material in the tool, but this will be shown during the hands-on training tomorrow. You will see that there is already a list of different polymers, but you can also do the modeling for another type of polymer that is not yet in the list, but then you need to have also some additional data for this polymer. You also need to have information about the thickness of the food contact material layer and about the contact area. And then finally, you also need to have some information about the food that you want to use in contact with your food contact material. So you need to know the type of food. You also need to know the volume of the food and the temperature at which the food will be stored. And when you have all this information, you will thus then be able to do the modeling of the concentration of your target chemical in the food at a certain time point. So then after developing this model, as I explained before, we also did some validation. And to do this validation, we used the experimental data that are reported in the Begley et al. Paper of 2005. And in fact, what we did is and that we then plotted the simulated concentration that we thus modeled with our migration model against the experimental concentration for different types of polymers. And this is in fact how this outcome looks like. And so here you have the experimental concentration in the food, and here you see then the predicted concentration. And you see, in fact, that there is a very good correlation between both. Again, as I mentioned before, we used in this migration model the diffusion coefficient calculated by the Bringers relationship and the partition coefficient calculated by Huang's model. Now, of course, what's very important if we want to use a migration model within a regulatory context, we want also to ensure that we are not underestimating the migration. And therefore, an exercise was performed where we, in fact, looked when we have a certain threshold, if we would apply our migration model, if we would have some misses, that we would just under predict in the migration, and that in the end, the compound would be in a lower migration tier, and then would be the case in reality. And here you see this the outcome of the exercise, and you see in fact that we have a high number of hits and correct negatives, and that we have only a very limited number of misses, and also some limited number of false alarms. So on this slide, you see more detailed information on the different metrics for evaluating the performance of the migration model. But overall, I will not go into detail. We can conclude that there was a good performance of the migration model. What's also an important advantage of the migration model compared to the already existing migration models is that the model also allows to do some probabilistic modeling. So you will see when you open the tool, and this will also be demonstrated tomorrow, and that you have also the possibility to provide a probability density function of a certain parameter. So not just one value, but also a kind of distribution. And then the model will do some random sampling for each uncertain parameter. And based on that, the model will provide you an indication about the uncertainty. So here you can see then the outcome of the uncertainty analysis with different percentiles. And so you can see overall, if we have the 95 percentile, that we have there's also a very good outcome. So this is with respect to the migration model. So we have also compiled all this information in a publication, and that has been submitted and approved for publication in Food and Chemical Toxicology. So normally it will very soon become available. And so now I will maybe briefly hand the word to Philippe if you want to to make some additions to the information about the migration model.
No, thank you, Birgit. It was perfect.
Okay, good. So then I will move to the second part, which is this the models that we have integrated in the VERMEER FCM tool to provide some information about the hazards. So there's the toxicological endpoints. And therefore, we have selected models that are available in the VEGA-HUB. But in the VEGA-HUB, there are currently about or even more than 95 models. And of course, not all of these are relevant for the food contact materials. So in fact, we selected those that are relevant for the food contact materials. And to do that, in fact, so we started again from the toxicological requirements as they are specified in the notes for guidance. And so as I've shown you before, even at the lowest migration level, we just need genotoxicity data. And there, we need not only data for gene mutations, but also for structural and numerical chromosome aberrations. So what we did in the end is, so we looked then in VEGA, which models do we have that are linked to gene mutations. And in fact, within VEGA, there are 4 individual mutagenicity models, but also a consensus model, which in fact combines the outcome of these 4 individual models. So what we have done is that in the VEGA FCM tool, we have integrated integrated the consensus model. Also, on the other hand, we have integrated a model for predicting in vitro micronucleus activity, but currently also in the VEGA-HUB, there is now also a model for in vivo micronucleus activity, so this will also be integrated in the VERMEER FCM tool. With respect to subchronic oral toxicity, a model to predict NOAEL values was included. Although there we have to highlight and that the reliability of this model for food contact materials is not always that good, but there's also work being done to develop newer models to predict these NOAEL values, and then also more target tissue specific. So in the future, also these models can then be included in VERMEER FCM. And to have an indication about the potential of a compound to accumulate in man, the log P value can also serve as a kind of index. And then with respect to when we look at the highest tiers, so then we also need data on reproductive and developmental toxicity. So there we have also some models. And finally, also different models for carcinogenicity were included. And there was not yet a consensus model in VEGA. So for this reason, also a kind of consensus model has been integrated in the VERMEER FCM tool. So just also very briefly, some more details about these VEGA models to predict the toxicological endpoints. So for the endpoints, first of all, there will be an indication about the hazard outcome. So for example, for carcinogenicity, if we look at the Antares model, there will be an indication whether the compound is considered to be predicted as non-carcinogen, possible carcinogen, or carcinogen. And then for each of these models, there you will see that there is also an applicability domain index. And in fact, this applicability domain index gives you an indication about the reliability of the predicted outcome. And so what we also wanted to do was to combine this information into one score. So in order to do that, we first translated the outcome into a kind of score. So you see here that for non-toxic, there was a 0. If it was toxic, it was a 1. And then you have here also the situations in between. And then this value was then corrected by the applicability domain index. So that in the end, you have a kind of numerical probability of toxicity, which is maybe a bit vague, but to show you with an example. So if you have, for example, for mutagenicity, an outcome with your model that it's predicted mutagenic with an applicability domain index score of 0.3, you will have in the end an outcome of 0.65, indicating that your compound is predicted as mutagenic, but with a rather low reliability. So more details on how the VERMEER FCM tool really looks like and how it works will be shown tomorrow during the hands-on training with some case studies. But just to show you very briefly, this is how the tool looks like. So in fact, it is composed out of different modules. So we have on one hand the module on migration, which allows us this to model the migration of the compound from the food contact material into the food. We also have some module providing some regulatory information, which means, in fact, that the tool will allow you to quickly check whether the compound in which you're interested is already included in Annex 1, so in this positive list, so that you know whether it has already been approved to be used in plastic food contact materials, and also automatically the specific migration limits, if available, and the restrictions of use will also be displayed. And then on the other hand, we have, of course, also the different modules related to the hazards. And so each of these is corresponding to a different migration level. So the input that you need, so you need to have some information on your chemical, food contact material, and food to be able to run the different modules. And the output will then be, as I just explained, some regulatory information an estimate of the migration, and information about the toxicological endpoints. And in fact, it's up to you to decide which modules you want to use. So if you only are interested in migration, you can only run the migration model. But if you want to have all information, then you can just run the different building blocks of the tool. And then maybe just to end with, how do we see the possible applications of the VERMEER FCM tool? So as I just explained, as an applicant, it's really of interest from the beginning already to know to what extent your compounds will migrate. And of course, also to see what the impact is of certain parameters. So by using the tool, you can really easily change different parameters to see in the end what the impact will be on the migration. On the other hand, it also allows to collect the information on the possible hazards of your compounds of interest. And it also allows you to quickly check whether your compound is already included in Annex 1, so whether it's already used for plastic food contact materials. So overall, we really think that this tool can help to support the risk assessment of compounds used in food contact materials. So that's it from my side. So if you want to have more information, you can certainly also have a look to the website. We are also, of course, available to answer some questions, and more details and really demonstrations on how the tool works will be shown tomorrow during the hands-on training.